Nature of matter. Nature of matter. What is matter? Matter is anything that has mass and occupies space. Matter gives us almost everything that is visible and invisible. Matter is present in animals, plants, airs, water, earth, etc. It is perfect to conclude that God created matter and used matter to create the world. Properties of matter. In science, the term properties means a quality that helps in recognizing a substance and differentiate it from other substances. For example, though both common salt, that is sodium chloride, and sugar are white in color, by their taste, we can differentiate one from the other. We can use the property of smell to differentiate water from kerosene. We can use the property of magnetization to differentiate iron from wood. Physical properties of matter. A physical property is a property that can be known without using chemical processes. The following are the physical properties of matters. 1. Volume. The volume of a matter tells us how big or small a substance is, or how large or small the space it can occupy. 2. Density. The property of a matter that makes a substance to possess more or less mass or weight than another substance of the same size is known as density. This explains why a piece of stone is heavier than a piece of wood of the same size. It is the reason why honey is heavier than water of the same volume. We can use density to differentiate one substance from another. 3. Boiling point. Boiling point is the temperature at which a substance boils and turns to vapor. A standard definition of boiling point is the temperature at which the pressure exerted by the surrounding upon a liquid is equal to the pressure exerted by the vapor of the liquid. Gas, liquid, and solid can boil. Solid melts first, and at a certain temperature, if the heating continues, the liquid boils. When gas is liquefied, it can boil at a certain temperature. No two substances, be it solid, liquid, or gas, have the same boiling point. 4. Melting point. The melting point of a solid is the temperature at which it changes from solid state to liquid state. No two melters melt at the same temperature. We can use melting point to differentiate a metal from other metals. 5. Temperature. Temperature is the degree of hotness or coldness of a body. With the aid of thermometer, we can measure the temperature of a body accurately. 6. Color. Many solids, liquids, and some gases have colors. We can use their colors to identify them. This is the list of few metals and their color. Gold, yellow. Potassium, white. Iron, silvery gray. Copper, reddish brown. The only two elements that are liquid at room temperature are mercury and bromine. Mercury is silvery white, while bromine is reddish brown. Mercury is regarded as metal. Bromine is regarded as non-metal. Oxygen is a colorless gas. Ozone is a pale blue gas. Fluorine is a pale yellow gas, while chlorine is a greenish yellow gas. 7. Taste. Taste is the sensation produced by the tongue in response to certain chemicals. Substances can be identified by their taste. It is not advisable to taste a substance in the laboratory. In science, all substances that are sweet in taste are considered as sugar. Examples of sugars are sucrose, fructose, galactose. Sugar tastes sweet. Dilute acids taste sour. Alkali tastes bitter. Water is tasteless. 8. Solubility. Solubility is the ability of a solid, liquid, or gas to dissolve in another thing to form a solution. We can differentiate a substance from another if they look alike by dissolving them in a solvent. A solvent is something in which another thing is dissolved, and then we observe how soluble they are. For example, ammonium gas, hydrogen chloride gas, and sulfur 4 oxide gas are very soluble in cold water. Nitrogen gas and methane don't dissolve in cold water at all. Carbon 4 oxide and chlorine are only slightly soluble in cold water. 9. Thermal conductivity. Thermal conductivity is the ability of a material to conduct heat. Substances which allow it to pass through them easily are called conductor. Examples of conductor are iron, silver, copper, aluminium, etc. Substances which only allow little amount of heat to pass through them are called semiconductors. Examples of semiconductor are silicon and germanium. While substances which do not allow it to pass through them at all are called insulator. Examples of insulator are clay, brick, tiles, glass, wood, cement, etc. 10. Viscosity. Viscosity can be defined as the quantity that shows the internal friction in a fluid. This property is possessed only by liquid and gas. If you are given 3 bottles that contain different liquids, water, palm oil, and honey, and you want to pour each of the liquid into another container, you observe that water will flow out easily, while honey will flow out sluggishly. So we say honey is more viscous than water and palm oil. 11. Hardness. Hardness can be defined as the ability to resist deformation. Hardness is mainly the property of metal. If you try to deform metals like lead, zinc, copper, and steel, you will realize that lead will change shape very easily, while steel will be the hardest to deform. So we can distinguish one solid from another using their hardness. Chemical properties of matters. Chemical properties of matter. The most important chemical properties of matter is reactivity. We can differentiate between 2 elements using their reactivity. The most reactive element is fluorine, the first element in the halogen group. The most reactive metal is francium, the last alkaline metal. However, francium is an unstable radioactive element, only found in trace ammon. The most reactive metal that has a stable isotope is cesium, which is located directly above francium on the periodic table. Helium is the least reactive element. Metals like sodium, potassium, calcium, copper, magnesium, zinc, etc. react readily with other substances. Metals like gold, silver, and platinum don't react at all. Physical change. Physical change is a change that can be reversed and in which the identity of the substances that underwent change is maintained. 1. Physical change is reversible. 2. In physical change, no new substance is formed. 3. The substances which change can still be recognized. Examples of physical change are dissolving sugar in water, dissolving salt in water, evaporation, melting, boiling, sublimation, etc. Chemical change. A chemical change is a change which cannot easily be reversed and in which new substances are produced. In a chemical change, the new substances formed is different from the substances which form it in every way and cannot be changed back to the substance which formed it. Examples of chemical change are burning, rust, decay, fermentation, digestion of food, neutralization reaction, etc. Differences between physical and chemical change. Differences between physical and chemical change. Number one, a physical change is reversible. A chemical change is not easy to reverse. In fact, there are some chemical change which are not reversible at all. Number two, in a physical change, there is no change of mass. This means the addition of the masses of the substances that form the product will be the same as the addition of the masses of the substances that are present in the product. But in a chemical change, there is a change of mass. 3. In a physical change, no new substances are formed. But in the chemical chain, new substances are always formed. 4. In a physical chain, there is no heat change. That is, there is no release or absorption of heat. Whereas in a chemical chain, there is a great amount of heat change. That is, a large amount of heat is absorbed or evolved.